Okay, here's our classwork for Tuesday, January 30th, our second day of talking about inheritance. Okay, uh, we're given a class called Monster on this handout here. Monster. It's got an instance field for name, and it's got a constructor that's a default constructor. I know that because it's empty parentheses. It just sets the name to Monster, and a second constructor that takes a string parameter, and that's what it initializes my name to, and then a toString method that just returns the name. That's all a monster is the name. Okay, so we have to use that class to make a subclass of it. There's all kinds of monsters. There's werewolves, there's zombies, there's vampires, all kinds of monsters. And this monster is a werewolf. So we don't say public class werewolf is a monster. That's not the Java. The Java is extends. It means the same thing. Remember our author in his lecture video says he doesn't know why the inventors of Java didn't say inherits. That might be a more explicit name, but it's called extends. We saw that Monday briefly, and also Monday's homework. So extend class monster to make a werewolf. A werewolf is a monster. I just said that right here with extends. Werewolf is a monster. It has all the properties and behaviors of a monster, and it also has properties of speed and age. Properties are the instance fields. Okay, some authors call them instance fields. Some refer to them frequently as properties. Behaviors are like the methods, the actions. What does it do? Okay, if there was a speak method in the monster class, that would be a behavior. If there was a run method or a walk method, that'd be a behavior. Common one is speak. So it has all the properties of a monster. That means it has my name. It's going to inherit my name. Okay, it inherits my name. Okay, it gets that for free. It's inherited. We don't type in private string my name. Please don't do that in our next quiz. But it has additional properties. Private double speed, it says, and private int age. Okay. Now it says you must provide 4 constructors. So I'll just go in here with public werewolf, and I'll copy and paste this 3 more times to get me started. The first one is a default constructor. That means the parentheses are empty. Good. The second one, name only. What's the name? Name is a string. You can go string n or string name, whatever. Okay, we'll go string n for name. I'll do name. Third one only gets speed and age. Speed and age. So speed is a double. I'll put S. Be SP, and age, int A for age. And the last one gets name, speed, and age. So string name, double SP, int A. And also must provide a toString method. Now I'm not near done with the constructors, but I want to make this bigger. So let me just put the bare bones signature for the string here. And so the job of every toString in the world is to make a string, and then we're going to add to it the instance fields, okay, and then return it. That's pretty much what every toString does we've ever written, at least so far. There's some weird ones out there, no doubt, but that's what a basic toString does. So we'll complete that in a second. Okay, now it's good form to call the default constructor of the superclass, okay, on the top line of this class's default constructor. Okay, super followed by parentheses first of all. Super followed by parentheses calls the superclass's constructor. Now, which one? This one calls the constructor with empty parentheses, the default constructor. Okay? If I have something to give it, a constructor, like name here, I'm saying, hey, monster class, store this name inside my name. Okay? Super takes us to the monster class. Once followed by parentheses, it goes to the constructor. And which constructor? The one that gets a string. All right. Is there a string to give the constructor in this one? No, I don't have a string. So this one here is going to be just super empty parentheses. Is there a string that this guy has to give to the monster class constructor? Yes, there is. It's got a string. So super name. All right. So if you want to initialize name to something, you got to do it this way. You could not do my name equals name. Java's going to give you a compile error saying my name has private access in the monster class. You can't touch it. You cannot touch it. Okay. So super followed by parentheses calls a constructor. Now the rest of this is old October stuff. The quiz directions might say to initialize speed and age to a certain number. I didn't. You can do explicitly 0 for each, whatever you wanted to today. I don't care. Right? I don't care. And if you don't do that, it makes it 0 anyway. Okay? But it is good form in many circles, I think, to do that, to explicitly put it in there, even though you don't have to. I don't know. I've never really programmed in the real world. I've just done it in college and got ready for you guys to take the exam with you. I don't know for sure. And then down here, same thing. How's that looking? 0, 0, 0, 0, SPA. I think that's good. Okay, so we saw the word super for the first time in those constructors. When it's followed by parentheses, it's calling a superclass's constructor. When it's followed by a dot, then it's just getting you in the class, and that's that, after that dot, it's going to try and access. Okay, so the first thought here, if I wasn't helping you much, you might try super dot my name. Okay, super got it in the class with those constructors. That was great. But my name is still private, and this is not going to work. Okay, this is a good guess. It's pretty intelligent. It's just it doesn't work that way. My name is private in a different class, and BlueJ is going to remind us of that with an error message right there. Okay, so we can't get to the private my name. How are we going to access my name and put it back here in the string? What is public in this class that returns my name? Well, the toString does. The toString in the monster class does. Okay, so we're in the toString method of the WereWolf class, and I want to call the toString method of the monster class. If I just do this, you might think, well, BlueJ knows I'm not stupid, hopefully. I'm going to call somebody else's toString. No, that's not how it works. It's going to look inside this class for a toString method first, and it finds it. It's going to call this method it's inside of. Can you see that? We're going to keep on hitting this call and going back to the top over and over and over and over. And I think it more or less runs out of memory when it does that too many times. If I run it now, actually I don't have it set up, do I? Let's see the compile. Yeah, let's see. There it is, a stack overflow. Okay, there's not enough memory available. The stack is BlueJ or Java's memory stack, right? pretty advanced concept there. But anyway, that's what's happening. It's calling itself. So to make it call the monster one, well, you might make another good guess that's wrong. Monster.toString. And that could work if the toString method was static. And if this toString method was static, right? Static methods only call other static methods. That's all. They can't call non-static methods. But that's going to be an error too because they're not static. So what do we do to get in that monster class? What do we do to get in that super class? We put super in front. Right, and there it is. And you can check out my monster tester here briefly. I hope, see, yeah, there it is. I've got some monsters up there testing the super class. And I've got some werewolves down here testing a subclass. Okay, so you can try that. And I'll be seeing Willie and Wanda on the screen. They're my werewolf names. And when I run it, there's Willie and Wanda, my werewolves. All right. Thanks for watching. Good luck with the zombie homework.